Hello everyone. In this video we are going to discuss about hashes. So encryption usually used for making the data unreadable for the third party, and of course the data is encrypted during transfer over network could easily changed or compromised or something may happen, and that will lead to the situation when the receiver will not able to read the original data, or it will read it with some errors, and that's where the hashes comes in. So what the hash is a fixed length string, and its length may be 128 bits or 160 or 256 bits or something longer, and this length depends on the algorithm that is used for creation of the hashes. So how this has the algorithm usually works, it takes input data, and this data may be variable length, so it may be just a single word, or it may be a sentence, may or even may be a file. So when this hash function is applied, it creates a fixed length hash based on the input data in it, and it creates irreversible hash. So what it means? It means if you have a hash and if you don't know what is the data on the input, you are not able to retrieve the data from the hash. Why? Because some hash may be created for unlimited, let's say infinite quantity of different inputs, and that's why hash function is one way. So we can create a hash based on the data, but we are not able to retrieve the data from the hash. So another important characteristic of any function, that is, each time when you slightly change the input data, when you change even a single character or a single dot inside the file, that the hash will change completely. Again, it makes even more and short character even more irreversible. And short of characteristic of a hash function, that is, they don't require any key. So we take only data, take the function and create using the hash function special hash. But why we need hash and hash functions? So let's check what is the use of the hash. So let's have a look into this diagram. In this diagram we have a data and we have hashed it, and it will be sent over the network and it will be received in other side. Okay, so there are two sides in this details. So we'll see what happens in this one. The hash function is applied to the original data and it creates the hashes, and after that data along with the hash are sent over a network. So the receiver receives the data and separate the limb, and now the data, it will, like, the data and the hashes will be separated, and the same hash function is applied over the data, so it will create the hash. So and if and the we already received one hash, so we will compare these two hashes. If the, like, hashes are matching, then we received the proper data over the network, so the data is not, like, not changed over the network. So we have, like, like we have a proof that the data is not mutated or not changed anything inside the data. So that is the purpose of the hash. So it verifies the integrity of the data. So again, in this scheme, we ensure using the hash function and hash algorithm that is a piece of data during the transfer over the network here was not changed. Of course, we should not take care of keep some of this data. Usually encryption happens before the creation of the hash. His algorithm worked in such a way that even small change in the data will lead to creation of completely different text and different hashes. So, and if at least one bit data was changed, and same way here during the transfer, then here we will get completely different hash, and during the comparison we will get different result. And usually when hash doesn't match, the receiver simply rejects the data and does nothing with it. That's how that's how this hash function are used for the data integrity check. So we perform not just integrity check of the data, but we also authenticate the sender. But again, please notice that keys are optional. There is an option to have a key and verify the authenticity of the user who sent the data. So that we will check in next lectures.